Find the zeros of f of x equals x cubed plus 8. Now, find the zeros means, let's just set this up like this. 0 equals x cubed plus 8. Now, x cubed plus 8 should look familiar to you. X cubed is a cube. 8 is also a cubed. It's 2 cubed. So what we have is a sum of cubes. Similar to difference of squares, there's sum of cubes, difference of cubes. There's no such thing as sum of squares, but there is a sum of cubes. And it looks a little something like this. Let's just say you have a cubed plus b cubed. That's going to be the same thing as a plus b times the quantity a squared minus ab plus b squared. Now, in this case, what's a, what's b? Well, if we're comparing a cubed to x cubed, then a is x. And if we're carrying b cubed to 8, which is 2 cubed, then b is 2. So let's fill this in using the letters. A is now x, okay? B is now 2. So a squared is x squared minus, now let's be a little clever here, x times 2 is going to be 2x, and b squared is going to be 4. Now, let's not forget the original problem. This guy, x cubed plus 8, is now what's here in green, and originally it's equal to 0. So I'm not sure if I can factor this out, and I'm not even going to try to, but if my job is to find the zeros, I have one of them. And one of my zeros is going to be x equals negative 2, because I'm using the zero product property. Now, what I also know is this chunk right here is equal to 0. And we could probably use the quadratic formula to do it. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. More singing. So let's plug stuff in. A is an invisible 1. B is negative 2, C is 4. So x equals negative 2, positive 2, plus or minus the square root of b squared, which is going to be negative 2 squared, so 4, minus 4 times a, 1, times c, 16, all over 2a, which is 2 times 1, which is 2. This ends up being 2 plus or minus the square root of negative 12 over 2. Now, negative 12, or regular 12, is 4 times 3, which means 2 times 2 times 3. So if I wanted to, I can take that and turn that into the square root of negative 2 times 2 times 3, which means we can bring out a 2. Not only that, we can bring out an I, and we're left over with this square root of 3, all of this being over 2. Now I have a 2 and a 2 and a 2, so let's deal with that. 2, let's pull it out, leaves me with 1 plus or minus I root 3, close it, all over 2. The 2's cancel, and my other possible answers are going to be x equals 1 plus or minus I root 3, which goes along with negative 2. Those are my 3 answers. So one was simple, one was quadratic formula. All of this means I have 3 answers, which makes sense. According to the fundamental theorem of algebra, I'm going to have 3 answers here. 2 of them are complex. 1 of them is real. Fun, 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 fun.